Welcome to ExHubMCQs channel. Get ready for chapter Magnetic Effects of Electric Current, 100 expert-crafted MCQs for perfect exam preparation. 1. What does the deflection of a compass needle near a current-carrying wire indicate? Option A. Current has no effect on the compass. Option B. Current produces a magnetic field. Option C. Magnetic fields and electricity are unrelated. Option D. Current destroys the compass needle. The correct answer is option B. Current produces a magnetic field. Explanation. The deflection of the compass needle demonstrates the magnetic effect of electric current. It shows that an electric current-carrying conductor generates a magnetic field as discovered by Hans Christian Ørsted. MCQ 2. What is represented by the concentric circles around a current-carrying wire? Option A. Electric field lines. Option B. Magnetic field lines. Option C. Neutral charges. Option D. Gravity lines. The correct answer is option B. Magnetic field lines. Explanation. The concentric circles represent magnetic field lines around a straight conductor. These lines are produced due to the magnetic field generated by the flow of current in the wire. MCQ 3. Which rule is used to determine the direction of the magnetic field around a conductor? Option A. Fleming's right-hand rule. Option B. Right-hand thumb rule. Option C. Left-hand thumb rule. Option D. Maxwell's screw rule. The correct answer is option B. Right-hand thumb rule. Explanation. The right-hand thumb rule states that if a current-carrying conductor is held in the right hand with the thumb pointing in the current's direction, the curled fingers represent the magnetic field's direction. MCQ 4. What happens to the magnetic field when the current through a wire is reversed? Option A. The field disappears. Option B. The field remains the same. Option C. The field reverses direction. Option D. The field doubles in strength. The correct answer is option C. The field reverses direction. Explanation. When the direction of current is reversed, the direction of the magnetic field also reverses. This can be observed by using a compass near the current-carrying wire. MCQ 5. What is the shape of the magnetic field lines around a bar magnet? Option A. Straight lines. Option B. Concentric circles. Option C. Closed curves. Option D. Random shapes. The correct answer is option C. Closed curves. Explanation. Magnetic field lines around a bar magnet form closed curves, emerging from the North Pole and merging at the South Pole and continuing through the magnet. MCQ 6. What does the density of magnetic field lines indicate? Option A. Strength of the magnetic field. Option B. Length of the magnetic field. Option C. Direction of electric current. Option D. Shape of the magnetic field. The correct answer is option A. Strength of the magnetic field. Explanation. The density of magnetic field lines shows the strength of the magnetic field. The field is stronger where the lines are closer and weaker where they are farther apart. MCQ 7. What property of the magnetic field lines makes them unique? Option A. They intersect each other. Option B. They never intersect each other. Option C. They are random in nature. Option D. They are confined to the poles. The correct answer is option B. They never intersect each other. Explanation. Magnetic field lines never intersect because if they did, it would imply that the magnetic field has two directions at the same point, which is impossible. MCQ 8. What is the direction of magnetic field lines inside a bar magnet? Option A. From North Pole to South Pole. Option B. From South Pole to North Pole. Option C. Circular motion around the magnet. Option D. Randomly oriented. The correct answer is option B. From South Pole to North Pole. Explanation. Inside a bar magnet, magnetic field lines travel from the South Pole to the North Pole, completing the closed loop of field lines. MCQ 9. What does a solenoid consist of? Option A. A single loop of wire. Option B, multiple circular loops of wire. Option C, a straight wire. Option D, a pair of bar magnets. The correct answer is option B, multiple circular loops of wire. Explanation. A solenoid is a cylindrical coil consisting of multiple circular turns of insulated copper wire that generates a uniform magnetic field when current flows through it. Ec 10. What is the magnetic field inside a solenoid like? Option A, 0. Option B, non-uniform. Option C, uniform. Option D, strong only at the ends. The correct answer is option C, uniform. Explanation. The magnetic field inside a solenoid is uniform, as indicated by parallel straight field lines. This uniformity makes it useful in creating electromagnets. MCQ 11. What happens to the deflection of a compass needle when current through a conductor is increased? Option A, deflection decreases. Option B, deflection remains unchanged. Option C, deflection increases. Option D, deflection reverses. The correct answer is option C, deflection increases. Explanation. When the current through a conductor is increased, the magnetic field around the wire becomes stronger, resulting in greater deflection of the compass needle. MCQ 12. What rule is used to find the direction of force on a current-carrying conductor in a magnetic field? Option A, right-hand thumb rule. Option B, Fleming's left-hand rule. Option C, Ampere's law. Option D, Maxwell's rule. The correct answer is option B, Fleming's left-hand rule. Explanation. Fleming's left-hand rule states that if the thumb, forefinger, and middle finger of the left hand are stretched mutually perpendicular, the thumb shows the direction of motion or force, the forefinger indicates the magnetic field, and the middle finger represents the current. What is the unit of magnetic field strength named after Hans Christian Ørsted? Option A, Ampere. Option B, Ørsted. Option C, Tesla. Option D, Weber. The correct answer is option B, Ørsted. Explanation. The unit Ørsted is named after Hans Christian Ørsted, who discovered the relationship between electricity and magnetism in 1820 by observing compass deflection near a current-carrying wire. MC 14. Which device uses a solenoid to create a strong magnetic field? Option A, transformer. Option B, electromagnet. Option C, galvanometer. Option D, ammeter. The correct answer is option B, electromagnet. Explanation. An electromagnet uses a solenoid with a core of soft iron to produce a strong magnetic field. It is widely used in devices like electric motors and magnetic cranes. 50. How does increasing the number of turns in a solenoid affect the magnetic field? Option A, increases the field strength. Option B, decreases the field strength. Option C, has no effect. Option D, reverses the direction of the field. The correct answer is option A, increases the field strength. Explanation. Increasing the number of turns in a solenoid enhances the magnetic field because the fields from individual turns add up, creating a stronger net effect. M16. What is the direction of the magnetic field outside a bar magnet? Option A, from north to south. Option B, from south to north. Option C, circular around the poles. Option D, randomly oriented. The correct answer is option A, from north to south. Explanation. Outside a bar magnet, magnetic field lines originate from the North Pole and merge at the South Pole, completing the closed loop inside the magnet. What happens to a current-carrying conductor when placed in a magnetic field? Option A, it experiences a force. Option B, it stops conducting electricity. Option C, it heats up. Option D, its resistance increases. The correct answer is option A, it experiences a force. Explanation. A current-carrying conductor placed in a magnetic field experiences a force, as per Fleming's left-hand rule. The force depends on the current, field strength, and their relative directions. Q18. Which rule helps find the direction of induced current in a rotating coil? Option A, Fleming's right-hand rule. Option B, Fleming's left-hand rule. Option C, right-hand thumb rule. Option D, Ampere's circuital law. The correct answer is option A, Fleming's right-hand rule. Explanation. Fleming's right-hand rule determines the direction of induced current. The thumb points in the motion's direction, the forefinger in the field's direction, and the middle finger in the current's direction. What ensures safety in appliances with metallic bodies? Option A, circuit breaker. Option B, earthing. Option C, insulated wire. Option D, fuse. The correct answer is option B, earthing. Explanation. Earthing connects the metallic body to the earth using a low-resistance path, preventing electric shocks by keeping the potential of the appliance's body at ground level. What is the function of a fuse in domestic circuits? Option A, increase voltage. Option B, provide magnetic shielding. Option C, prevent overloading and short-circuiting. Option, enhance current flow. The correct answer is option C, prevent overloading and short-circuiting. Explanation. A fuse is a safety device that protects circuits from damage due to overloading or short-circuiting by breaking the circuit when excessive current flows through it. MP21. What happens to the magnetic field strength as you move away from a current-carrying wire? Option A, increases. Option B, decreases. Option C, remains constant. Option D, doubles. The correct answer is option B, decreases. Explanation. The magnetic field strength around a current-carrying wire decreases as the distance from the wire increases. This is evident from the wider spacing of the magnetic field lines farther from the wire. C22. What rule is used to determine the direction of force on a current-carrying conductor in a magnetic field? Option A, right-hand thumb rule. Option B, Fleming's left-hand rule. Option C, Ampere's law. Option D, Maxwell's rule. The correct answer is option B, Fleming's left-hand rule. Explanation. Fleming's left-hand rule states that if the thumb, forefinger, and middle finger of the left hand are mutually perpendicular, the thumb indicates the force's direction, the forefinger shows the magnetic field, and the middle finger indicates the current. MC23. What is the direction of the magnetic field inside a bar magnet? Option A, from North Pole to South Pole. Option B, from South Pole to North Pole. Option C, circular motion around the magnet. Option D, randomly oriented. The correct answer is option B, from South Pole to North Pole. Explanation. Inside a bar magnet, magnetic field lines travel from the South Pole to the North Pole, completing the closed loop of field lines. What is the advantage of parallel connections in domestic circuits? Option A, equal potential difference across appliances. Option B, reduced power consumption. Option C, stronger magnetic field. Option D, simpler installation. The correct answer is option A, equal potential difference across appliances. Explanation. Parallel connections in domestic circuits ensure that each appliance receives the same potential difference, allowing them to operate independently without being affected by others. MCQ 25. Why don't magnetic field lines intersect? Option A, they have fixed lengths. Option B, magnetic fields have directionality. Option C, they are random in nature. Option D, magnetic fields are non-uniform. The correct answer is option B, magnetic fields have directionality. Explanation. Magnetic field lines do not intersect because it would imply that the magnetic field has two directions at a single point, which is physically impossible. MC 26. What does the right-hand thumb rule help determine? Option A, direction of electric current. Option B, direction of force. Option C, direction of magnetic field. Option D, strength of the magnetic field. The correct answer is option C, direction of magnetic field. Explanation. The right-hand thumb rule determines the direction of the magnetic field around a current-carrying conductor. When the thumb points in the current's direction, the curled fingers indicate the magnetic field's direction. MCQ 27. What happens to the magnetic field strength when a solenoid's current is doubled? Option A, doubles. Option B, halves. Option C, remains unchanged. Option D, reverses. The correct answer is option A, doubles. Explanation. The magnetic field strength inside a solenoid is directly proportional to the current flowing through it. Doubling the current doubles the magnetic field strength. M28. How does a short circuit occur in an electric circuit? Option A, excess voltage is applied. Option B, live wire and neutral wire touch. Option C, too many appliances are connected. Option D, circuit resistance increases. The correct answer is option B, live wire and neutral wire touch. Explanation. A short circuit occurs when the live wire and neutral wire come into direct contact, creating a low resistance path that results in a sudden surge of current. EMS 29. What is the function of an electric fuse in circuits? Option A, to decrease current. Option B, to regulate voltage. Option C, to prevent damage during overloading. Option D, to maintain a uniform field. The correct answer is option C, to prevent damage during overloading. Explanation. An electric fuse protects the circuit from overloading and short-circuiting by breaking the circuit when the current exceeds the safe limit, preventing damage to appliances. 30. What causes the formation of magnetic field lines in a solenoid? Option A, insulated wire. Option B, electric current. Option shape of the solenoid. Option D, type of material. The correct answer is option B, electric current. Explanation. Magnetic field lines in a solenoid are formed due to the electric current passing through the wire, which creates a strong uniform magnetic field inside the solenoid. MQ 31. Why are electromagnets preferred over permanent magnets in industrial applications? Option A, they are cheaper. Option B, they can be turned on and off. Option C, they are lightweight. Option D, they have weaker fields. The correct answer is option B, they can be turned on and off. Explanation. Electromagnets are preferred because their magnetic field can be controlled by switching the current on or off, offering flexibility and higher field strength compared to permanent magnets. MCQ 32. What happens to the magnetic field strength when the number of turns in a solenoid is increased? Option A, field strength increases. Option B, field strength decreases. Option C, field becomes non-uniform. Option D, field disappears. The correct answer is option A, field strength increases. Explanation. Increasing the number of turns in a solenoid increases the magnetic field strength, as the magnetic field produced by each turn adds up to create a stronger field. What is the direction of force on a current-carrying conductor in a magnetic field determined by? Option A, right-hand thumb rule. Option B, Fleming's left-hand rule. Option C, Ampere's law. Option D, Faraday's law. The correct answer is option B, Fleming's left-hand rule. Explanation. Fleming's left-hand rule helps determine the direction of force. The thumb indicates motion. The forefinger represents the magnetic field, and the middle finger indicates the current's direction when all three are mutually perpendicular. EMS 34. What happens when the direction of current in a solenoid is reversed? Option A, the field strengthens. Option B, the poles of the solenoid reverse. Option C, the field becomes uniform. Option D, the solenoid stops working. The correct answer is option B, the poles of the solenoid reverse. Explanation: reversing the direction of current in a solenoid reverses its poles. The north pole becomes the south pole and vice versa, as the magnetic field direction depends on the current's direction. MCQ 35. What is the shape of the magnetic field lines around a straight conductor? Option A, straight lines. Option B, circular. Option C, radial. Option D, random. The correct answer is option B, circular. Explanation: the magnetic field lines around a current-carrying straight conductor form concentric circles, indicating the direction of the magnetic field as determined by the right-hand thumb rule. EMS 36. Which rule is used to determine the direction of magnetic field lines in a circular loop? Option A, Fleming's right-hand rule. Option B, right-hand thumb rule. Option C, Ampere's circuital law. Option D, Fleming's left-hand rule. The correct answer is option B, right-hand thumb rule. Explanation: the right-hand thumb rule is used to determine the direction of magnetic field lines. Curling the fingers around the loop indicates the field direction when the thumb points in the current's direction. M37. What is the magnetic field inside a solenoid comparable to? Option A, magnetic field of a bar magnet. Option B, electric field of a charged sphere. Option C, gravitational field of the Earth. Option D, magnetic field of a straight conductor. The correct answer is option A, magnetic field of a bar magnet. Explanation: the magnetic field inside a solenoid is similar to that of a bar magnet, with a uniform field inside and field lines forming closed loops outside the solenoid. MCQ: the purpose of earthing in domestic circuits. Option A, to reduce power consumption. Option B, to prevent electric shocks. Option C, to enhance circuit efficiency. Option D, to increase current flow. The correct answer is option B, to prevent electric shocks. Explanation: earthing ensures safety by providing a low resistance path for current in case of leakage, preventing electric shocks and protecting users from harm. MCQ 39. What effect does the length of a current-carrying conductor have on the force it experiences in a magnetic field? Option A, increases force. Option B, decreases force. Option C, no effect. Option D, reverses force direction. The correct answer is option A, increases force. Explanation: the force experienced by a current-carrying conductor in a magnetic field is directly proportional to its length, as per the formula F equals BI sine theta. MCQ 40. Why are the magnetic field lines in a solenoid parallel inside the coil? Option A, to create a weak field. Option B, to create a uniform field. Option C, to prevent current leakage. Option D, to reduce resistance. The correct answer is option B, to create a uniform field. Explanation: the magnetic field lines inside a solenoid are parallel because they indicate a uniform field strength and direction, crucial for applications requiring consistent magnetic effects. MC 41. What is the purpose of a variable resistance in an electric circuit? Option A, to increase current. Option B, to control current. Option C, to decrease voltage. Option D, to measure resistance. The correct answer is option B, to control current. Explanation: a variable resistance, or rheostat, is used to control the current in an electric circuit by varying the resistance. By adjusting the resistance, the current flow through the circuit can be increased or decreased as needed. EMS 42. Why do magnetic field lines never intersect? Option A, they represent uniform strength. Option B, field direction is unique at a point. Option C, they are confined to the poles. Option D, they are imaginary. The correct answer is option B, field direction is unique at a point. Explanation: magnetic field lines never intersect because it would mean the magnetic field has two directions at the same point, which is not physically possible. The field at any point has a unique direction. MCQ 43. What happens to the magnetic field when a current-carrying wire is bent into a loop? Option A, field becomes weaker. Option B, field becomes stronger. Option C, field becomes uniform. Option D, field vanishes. The correct answer is option B, field becomes stronger. Explanation: bending a current-carrying wire into a loop concentrates the magnetic field, making it stronger inside the loop. This is because the magnetic fields from each section of the loop add up. MC44. What is the relationship between current and magnetic field strength? Option A, directly proportional. Option B, inversely proportional. Option C, no relationship. Option D, depends on wire material. The correct answer is option A, directly proportional. Explanation: the strength of the magnetic field is directly proportional to the current passing through the conductor. As current increases, the magnetic field becomes stronger. What is the use of a solenoid in electromagnets? Option A, to reduce electric resistance. Option B, to generate a strong magnetic field. Option C, to increase the electric current. Option D, to minimize energy loss. The correct answer is option B, to generate a strong magnetic field. Explanation: a solenoid is used in electromagnets to generate a strong magnetic field. The coiled wire produces a field, and the addition of a soft iron core amplifies the magnetic effect. MC46. How does an electric short circuit affect the current in the circuit? Option A, current decreases. Option B, current remains constant. Option C, current increases heavily. Option D, current alternates. The correct answer is option C, current increases heavily. Explanation: an electric short circuit causes a significant increase in current as the live wire comes into direct contact with the neutral wire, bypassing resistance and creating a high current path. M47. Why is the magnetic field strongest at the poles of a bar magnet? Option A, field lines converge at the poles. Option B, field lines diverge at the poles. Option C, the magnet's material is denser there. Option D, the field does not exist elsewhere. The correct answer is option A, field lines converge at the poles. Explanation: the magnetic field is strongest at the poles of a bar magnet because the field lines converge there, indicating a high concentration of magnetic force. M48. What is the direction of the force on a conductor if the current and magnetic field are perpendicular? Option A, parallel to current. Option B, opposite to magnetic field. Option C, perpendicular to both. Option D, along the field lines. The correct answer is option C, perpendicular to both. Explanation: when the current and magnetic field are perpendicular, the force on the conductor is perpendicular to both, as determined by Fleming's left-hand rule. M49. How can the magnetic field strength inside a solenoid be increased? Option A, by increasing the core resistance. Option B, by decreasing current. Option C, by using a soft iron core. Option D, by increasing the wire insulation. The correct answer is option C, by using a soft iron core. Explanation: inserting a soft iron core into a solenoid amplifies the magnetic field strength as the core becomes magnetized and adds to the overall field. The 50. What is the function of a domestic circuit fuse? Option A, to increase the voltage. Option B, to protect appliances from overcurrent. Option C, to regulate electricity flow. Option D, to increase circuit efficiency. The correct answer is option B, to protect appliances from overcurrent. Explanation: a domestic circuit fuse protects appliances and wiring by breaking the circuit when the current exceeds safe limits, preventing overheating and potential damage. MCQ 51. How are magnetic field lines oriented inside a bar magnet? Option: diverging from the center. Option B, converging towards the poles. Option C, from South Pole to North Pole. Option D, from North Pole to South Pole. The correct answer is option C, from South Pole to North Pole. Explanation. Inside a bar magnet, magnetic field lines are directed from the South Pole to the North Pole, completing the closed loop of field lines. MC52. What is the role of the earth wire in domestic circuits? Option A, to prevent voltage fluctuations. Option B, to protect appliances from damage. Option C, to reduce power consumption. Option D, to prevent electric shocks. The correct answer is option D, to prevent electric shocks. Explanation. The earth wire provides a safe, low-resistance path for current leakage, protecting users from electric shocks caused by faulty appliances or circuits. MCQ 53. Which material is typically used as the core of an electromagnet? Option A, copper. Option B, aluminum. Option C, soft iron. Option D, steel. The correct answer is option C, soft iron. Explanation. Soft iron is used as the core in electromagnets because it enhances the magnetic field strength and loses its magnetism when the current is switched off, making it ideal for temporary magnets. MCQ 54. How is the magnetic field distributed around a current-carrying circular loop? Option A, uniform throughout. Option B, strongest at the center. Option C, weakest at the center. Option D, randomly distributed. The correct answer is option B, strongest at the center. Explanation. The magnetic field around a current-carrying circular loop is strongest at the center, where the concentric field lines converge, indicating high magnetic field strength. 55. Why is a solenoid's magnetic field uniform inside it? Option A, due to its cylindrical shape. Option B, due to the uniform current flow. Option C, due to parallel alignment of field lines. Option D, due to its insulation. The correct answer is option C, due to parallel alignment of field lines. Explanation. The magnetic field inside a solenoid is uniform because the parallel alignment of the field lines ensures constant strength and direction throughout the coil. 56. What is the effect of a stronger magnet on a current-carrying conductor? Option A, increases the force on the conductor. Option B, decreases the force on the conductor. Option C, reduces current in the conductor. Option D, reverses the current direction. The correct answer is option A, increases the force on the conductor. Explanation. The force on a current-carrying conductor in a magnetic field increases with the strength of the magnet, as the force is proportional to the field strength. 57. How is the direction of induced current determined in a moving coil? Option A, Fleming's right-hand rule. Option B, Fleming's left-hand rule. Option C, right-hand thumb rule. Option D, Ampere's law. The correct answer is option A, Fleming's right-hand rule. Explanation. Fleming's right-hand rule determines the direction of induced current in a moving coil. The thumb indicates motion, the forefinger shows the magnetic field, and the middle finger shows the current direction. MC 58. What causes short-circuiting in domestic electrical systems? Option A, excess voltage. Option B, loose connections. Option C, contact between live and neutral wires. Option D, high resistance. The correct answer is option C, contact between live and neutral wires. Explanation. Short-circuiting occurs when the live wire and neutral wire come into direct contact, creating a low-resistance path that results in a surge of current. 59. What happens to magnetic field lines when a soft iron core is inserted into a solenoid? Option A, they weaken. Option B, they become denser. Option C, they reverse direction. Option D, they disappear. The correct answer is option B, they become denser. Explanation. When a soft iron core is inserted into a solenoid, the magnetic field lines become denser because the core amplifies the magnetic effect by becoming magnetized. MC 60. What does the deflection of a compass near a bar magnet indicate? Option A, the magnet has no field. Option B, the magnet has an electric charge. Option C, the magnet produces a magnetic field. Option D, the compass is faulty. The correct answer is option C, the magnet produces a magnetic field. Explanation. The deflection of a compass near a bar magnet indicates that the magnet produces a magnetic field, which interacts with the magnetic needle of the compass, causing deflection. MQ61, what does the spacing of magnetic field lines represent? Option A, direction of current. Option B, strength of the magnetic field. Option C, type of magnet used. Option D, length of the conductor. The correct answer is option B, strength of the magnetic field. Explanation. The spacing of magnetic field lines indicates the strength of the magnetic field. Closer lines represent a stronger field, while wider spacing indicates a weaker field. MCQ 62. What happens to the force on a conductor when the angle between the current and magnetic field is 90 degrees? Option A, force is 0. Option B, force is maximum. Option C, force becomes negative. Option D, force decreases. The correct answer is option B, force is maximum. Explanation. The force on a current-carrying conductor is maximum when the current and the magnetic field are perpendicular 90 degrees to each other, as per Fleming's left-hand rule. M63. Why is a fuse important in household circuits? Option A, to reduce electric bills. Option B, to prevent overheating and fire. Option C, to increase voltage. Option D, to regulate magnetic fields. The correct answer is option B, to prevent overheating and fire. Explanation. A fuse is a safety device in household circuits that protects against overheating and fire by breaking the circuit when excessive current flows, preventing potential hazards. M64. How does the distance from a current-carrying wire affect the magnetic field? Option A, field strength increases. Option B, field strength decreases. Option C, field strength remains constant. Option D, field becomes random. The correct answer is option B, field strength decreases. Explanation. The magnetic field strength decreases as the distance from a current-carrying wire increases. This is why field lines become wider farther from the wire. MCQ 65. What is the function of a rheostat in an electric circuit? Option A, to control the voltage. Option B, to vary the resistance. Option C, to reduce magnetic fields. Option D, to increase the circuit length. The correct answer is option B, to vary the resistance. Explanation. A rheostat is used to vary the resistance in an electric circuit, allowing control of the current flow and thus adjusting the performance of the circuit as needed. 66. Which device uses a solenoid to create a magnetic field? Option A, transformer. Option B, electromagnet. Option C, option D, capacitor. The correct answer is option B, electromagnet. Explanation. An electromagnet uses a solenoid to create a strong magnetic field. The solenoid's coiled wire generates a field that is amplified by a soft iron core. Q67. What causes the magnetic field lines to form closed loops? Option A, nature of the electric current. Option B, nature of the magnetic field. Option C, interaction between poles. Option D, conservation of magnetic flux. The correct answer is option D, conservation of magnetic flux. Explanation. Magnetic field lines form closed loops due to the conservation of magnetic flux. They originate at the North Pole and return to the South Pole, maintaining continuity. M68. How does increasing the current in a solenoid affect its magnetic field? Option A, increases the field strength. Option B, decreases the field strength. Option C, reverses the field direction. Option D, weakens the field at the center. The correct answer is option A, increases the field strength. Explanation. Increasing the current in a solenoid increases its magnetic field strength because the field is directly proportional to the current flowing through the solenoid. Case 69. What happens to the magnetic field inside a solenoid when the number of turns is doubled? Option A, field strength doubles. Option B, field strength halves. Option C, field becomes non-uniform. Option field disappears. The correct answer is option A, field strength doubles. Explanation. Doubling the number of turns in a solenoid increases the magnetic field strength, as the field produced by each turn adds up to create a stronger net field. 70. Why do we use green insulation for the earth wire? Option A, to signify live wire. Option B, to indicate it is neutral. Option C, to distinguish it as a safety wire. To prevent overheating. The correct answer is option C, to distinguish it as a safety wire. Explanation. The earth wire is insulated with green to distinguish it as the safety wire, which provides a low resistance path to the ground, protecting users from electric shocks. What happens to the force experienced by a conductor when the magnetic field strength is increased? Option A, force increases. Option B, force decreases. Option C, force remains the same. Option D, force reverses direction. The correct answer is option A, force increases. Explanation. The force experienced by a current-carrying conductor in a magnetic field is directly proportional to the magnetic field strength. Increasing the field strength increases the force acting on the conductor. M72. What is the direction of the magnetic field outside a current-carrying circular loop? Option A, from center to edge. Option B, concentric circles. Option C, perpendicular to the loop. Option D, randomly oriented. The correct answer is option B, concentric circles. Explanation. Outside a current-carrying circular loop, the magnetic field forms concentric circles around the wire. The direction of these circles is determined by the right-hand thumb rule. CQ 73. What is the purpose of the soft iron core in an electromagnet? Option A, to reduce current. Option B, to increase magnetic field strength. Option C, to prevent overheating. Option D, to reverse the magnetic field direction. The correct answer is option B, to increase magnetic field strength. Explanation. The soft iron core in an electromagnet enhances the magnetic field strength by becoming magnetized. It concentrates and amplifies the field produced by the solenoid. C74. What happens to the deflection of a compass as it is moved closer to a current-carrying wire? Option A, deflection increases. Option B, deflection decreases. Option C, deflection remains unchanged. Option D, deflection reverses. The correct answer is option A, deflection increases. Explanation. The deflection of the compass increases as it is moved closer to a current-carrying wire because the magnetic field strength is stronger near the wire. M75. How is the magnetic field distributed around a bar magnet? Option A, uniform. Option B, strongest at the poles. Option C, strongest at the center. Option, random. The correct answer is option B, strongest at the poles. Explanation. The magnetic field around a bar magnet is strongest at the poles, where the field lines converge, indicating a higher concentration of magnetic force. Why do magnetic field lines emerge from the north pole of a magnet? Option A, due to electric current. Option B, due to magnetic flux direction. Option C, due to the nature of the magnetic field. Option D, due to conservation of charge. The correct answer is option C, due to the nature of the magnetic field. Explanation. Magnetic field lines emerge from the North Pole because of the nature of magnetic fields. They indicate the field's direction, originating at the North Pole and ending at the South Pole. MCU 77. What happens when live and neutral wires come into direct contact? Option A, Circuit resistance increases. Option B, a short circuit occurs. The circuit becomes open. Option D, voltage drops to 0. The correct answer is option B, a short circuit occurs. Explanation. When live and neutral wires come into direct contact, a short circuit occurs, resulting in a sudden surge of current that can damage appliances and wiring. How does Fleming's left-hand rule help in practical applications? Option A, determines voltage direction. Predicts force on a conductor. Option C, measures current flow. Option D, indicates power usage. The correct answer is option B, predicts force on a conductor. Explanation. Fleming's left-hand rule is used to predict the direction of force on a current-carrying conductor placed in a magnetic field, aiding in the design of motors and other devices. Why do electric appliances have separate switches in domestic circuits? Option A, to regulate voltage. Option B, to ensure equal current flow. Option C, to allow individual control. Option D, to prevent magnetic fields. The correct answer is option C, to allow individual control. Explanation. Electric appliances have separate switches to allow individual control, ensuring safety and convenience by enabling independent operation without affecting other devices. MCQ 80. How does the strength of the magnetic field vary inside and outside a solenoid? Option A, strong inside, weak outside. Option B, weak inside, strong outside. Option C, uniform both inside and outside. Option D, non-uniform inside. The correct answer is option A, strong inside, weak outside. Explanation. The magnetic field inside a solenoid is strong and uniform, while it is weak outside. This characteristic is due to the field lines being concentrated inside the solenoid. Key 81. What happens to the force on a current-carrying conductor when the current is reversed? Option A, force direction remains the same. Option B, force direction reverses. Option C, force becomes 0. Option D, force doubles in magnitude. The correct answer is option B, force direction reverses. Explanation. When the current in a conductor is reversed, the direction of the force acting on it also reverses, as determined by Fleming's left-hand rule. 82. What is the significance of parallel connections in household wiring? Option A, reduces voltage drop. Option B, provides equal voltage to appliances. Option C, decreases total current. Option D, increases circuit resistance. The correct answer is option B, provides equal voltage to appliances. Explanation. Parallel connections in household wiring ensure that each appliance receives the same voltage, allowing them to function independently and safely without affecting other devices. MCQ 83. How does increasing the number of turns in a circular coil affect its magnetic field? Option A, decreases the field strength. Option B, increases the field strength. Option C, has no effect. Option D, reverses the field direction. The correct answer is option B, increases the field strength. Explanation. Increasing the number of turns in a circular coil amplifies the magnetic field strength because the contributions from individual turns add up, creating a stronger overall field. MCQ 84. Why does a solenoid produce a uniform magnetic field inside it? Option A, due to its cylindrical shape. Option B, due to the flow of current. Option C, due to parallel alignment of field lines. Option D, due to its insulation. The correct answer is option C, due to parallel alignment of field lines. Explanation. The solenoid produces a uniform magnetic field inside it because the field lines are parallel and evenly spaced, ensuring consistent strength and direction throughout the solenoid. MCQ 85. What happens to the magnetic field strength when a soft iron core is removed from a solenoid? Option A, field strength increases. Option B, field strength decreases. Option C, field strength remains constant. Option D, field lines disappear. The correct answer is option B, field strength decreases. Explanation. Removing the soft iron core from a solenoid reduces the magnetic field strength, as the core amplifies the field by concentrating the magnetic flux within the solenoid. MC 86. Which safety measure prevents electric shocks from appliances with metallic bodies? Option A, using a high voltage connection. Option B, earthing. Option C, increasing circuit resistance. Option D, adding extra wiring. The correct answer is option B, earthing. Explanation. Earthing protects users from electric shocks by providing a low-resistance path for leakage currents, ensuring the appliance's body potential is at ground level. MC 87. What is the result of short-circuiting in a household circuit? Option A, voltage increases. Option B, current decreases. Option C, current increases drastically. Option D, circuit becomes stable. The correct answer is option C, current increases drastically. Explanation. Short-circuiting causes a sudden and significant increase in current due to the direct contact of live and neutral wires, bypassing the normal circuit resistance and leading to potential damage. MCQ 88. How can the magnetic field direction be determined around a straight conductor? Option A, by using Ampere's law. Option B, by Fleming's right-hand rule. Option C, by right-hand thumb rule. Option D, by Maxwell's screw rule. The correct answer is option C, by right-hand thumb rule. Explanation. The right-hand thumb rule determines the magnetic field direction around a straight conductor. The thumb points in the direction of the current, and the curled fingers indicate the magnetic field direction. MC 89. What happens to the deflection of a compass needle when placed farther from a current-carrying wire? Option A, deflection increases. Option B, deflection decreases. Option C, deflection remains constant. Option D, deflection reverses. The correct answer is option B, deflection decreases. Explanation. The deflection of a compass needle decreases as it is moved farther from a current-carrying wire because the magnetic field strength weakens with distance. CQ 90. What is the relationship between the magnetic field strength inside a solenoid and the current? Option A, inversely proportional. Option B, directly proportional. Option C, no relationship. Option D, randomly varies. The correct answer is option B, directly proportional. Explanation. The magnetic field strength inside a solenoid is directly proportional to the current flowing through it, making the field stronger as the current increases. MCQ 91. What is the function of a fuse in a circuit? Option A, to increase voltage. Option B, to protect against overloading. Option C, to maintain constant resistance. Option D, to regulate current direction. The correct answer is option B, to protect against overloading. Explanation. A fuse protects the circuit from damage caused by overloading or short-circuiting by breaking the circuit when the current exceeds a safe limit, preventing potential hazards. MCQ 92. How does the length of a conductor affect the force it experiences in a magnetic field? Option A, force decreases with length. Option B, force increases with length. Option C, force is independent of length. Option D, force reverses direction with length. The correct answer is option B, force increases with length. Explanation. The force on a current-carrying conductor in a magnetic field is directly proportional to its length, as a longer conductor interacts with more magnetic field lines, increasing the force. MC 93. What is the role of a solenoid in an electric motor? Option A, generates a magnetic field. Option B, reduces circuit resistance. Option C, increases current flow. Option D, protects the motor from overheating. The correct answer is option A, generates a magnetic field. Explanation. In an electric motor, the solenoid generates a magnetic field that interacts with the motor's components, producing rotational motion essential for its operation. MQ94. What happens when the direction of current through a solenoid is reversed? Option A. The magnetic field becomes stronger. Option B. The magnetic field disappears. Option C. The poles of the solenoid reverse. Option D. The solenoid overheats. The correct answer is option C. The poles of the solenoid reverse. Explanation. Reversing the current direction in a solenoid reverses its poles, changing the north pole to south and vice versa, which alters the magnetic field's orientation. MCQ 95. How can the magnetic field around a straight conductor be visualized? Option A. Using electric field sensors. Option B. By sprinkling iron filings. Option C. With a voltmeter. Option D. By measuring resistance. The correct answer is option B, by sprinkling iron filings. Explanation. The magnetic field around a straight conductor can be visualized by sprinkling iron filings around it. The filings align along the field lines, showing their pattern and direction. MCQ 96. Why are the field lines inside a solenoid parallel? Option A, to create a stronger field. Option B, to ensure uniform field strength. Option C, to minimize energy loss. Option D, to prevent current leakage. The correct answer is option B, to ensure uniform field strength. Explanation. The field lines inside a solenoid are parallel to indicate a uniform strength and direction of the magnetic field, which is essential for applications requiring consistent magnetic effects. 97. What determines the strength of the magnetic field in a solenoid? Option A, the thickness of the wire. Option B, the number of turns in current. Option C, the length of the solenoid. Option D, the material of the coil. The correct answer is option B, the number of turns and current. Explanation. The strength of the magnetic field in a solenoid is determined by the number of turns in the coil and the current flowing through it, as both factors amplify the field. MCQ98. How does a short circuit affect a fuse in a domestic circuit? Option A, the fuse prevents current flow. Option B, the fuse melts and breaks the circuit. Option C, the fuse increases resistance. Option D, the fuse remains unaffected. The correct answer is option B, the fuse melts and breaks the circuit. Explanation. In the event of a short circuit, the excessive current causes the fuse to melt and break the circuit, protecting appliances and wiring from overheating and damage. MCQ99. What is the purpose of an earth wire in metallic appliances? Option A, to increase voltage. Option B, to enhance magnetic fields. Option C, to prevent electric shocks. Option D, to decrease current flow. The correct answer is option C, to prevent electric shocks. Explanation. The earth wire provides a safe path for leakage current, ensuring that the appliance's body remains at ground potential and preventing electric shocks. 100. What is the pattern of magnetic field lines around a bar magnet? Option A, concentric circles. Option B, straight lines. Option C, closed loops. Option D, randomly distributed. The correct answer is option C, closed loops. Explanation. The magnetic field lines around a bar magnet form closed loops, emerging from the North Pole, curving through the surrounding space, and merging at the South Pole. Thank you for watching ExHubMCQs channel. We hope these 100 MCQs on magnetic effects of electric current helped strengthen your understanding of key concepts like magnetic fields, solenoids, electromagnets, Fleming's rules, and circuit safety. Regular practice with multiple choice questions enhances conceptual clarity and boosts exam confidence. Whether you're preparing for school exams, competitive tests, or simply revising, our detailed explanations ensure that you not only memorize answers, but also grasp the logic behind them. Stay connected with ExHubMCQs channel for more chapter-wise MCQs, subject-wise quizzes, and expert explanations to make learning easy and effective. Don't forget to like, share, and subscribe to support our efforts in delivering quality educational content. For more chapters and subjects, check our playlists and turn on notifications so you never miss an update. Let us know in the comments which topics or subjects you'd like us to cover next. Keep learning, keep practicing, and remember, consistent effort leads to success. See you in the next session with more power-packed MCQs.